Okay, so welcome to today's tutorial, and we will be talking about controlling services and daemons. This is Red Hat Enterprise Linux 1. So just by opening statement, we all know that Red Hat is an operating system, just like any other operating system. And just the way you operate on a Windows operating system or using Windows operating system, you can also use Linux operating system. So the only differences between the Windows operating system and the Linux operating system is that Linux operating system is more of command-based, And Windows operating system is also more of graphical user interfaces. So this does not mean that when you interact with Windows operating system, that means that you cannot also use a command line. So you can also have, you also have the option of interacting with the command line in Windows operating system, and you also have the option of interacting with the graphical user interface using Linux operating systems such as Red Hat. So based on this chapter, which is chapter 9 on Red Hat Enterprise Linux 1, and it is actually version 8. So we have a chapter 9, which is all about controlling services and daemons. And in this particular part, we need to understand what are these services and how do we view these services? How do we check the status of these services? And then how can we manage all the service units or all the units as far as services are concerned? And again, what is the differences between services and daemons? So in this case, I'm taking you through this slide, and these are some of the things that we're going to cover. Number one, we're going to cover or to understand how do we control and monitor network services and system daemons or daemons using Systemctl. So we will base ourselves so much on trying to understand what Systemctl is. So remember, whenever the operating system is being started or is being booted up, you see there are processes that are actually happening. There we have a lot of background activities that are happening before the operating system is available for use. And through that process, we have a lot of activities. So it is being performed by something called the Systemctl. So in a detailed format, we will also talk about that. Then we will also try to understand list system daemons and the network services started by the Systemctl service and socket units. So Systemctl is actually like the mother of all, because for a service or a daemon or a network to be started, it must work hand in hand with the Systemctl. It must start from the Systemctl service. Then we also need to understand how do we control system daemons or daemons and the network services. So we also have the option, because we are talking about the Red Hat Linux or the Red Hat Enterprise Linux operating system. So it means that for us to interact with the Systemctl or for us to alter or modify the services that are within the system, then we need a command. And this command is Systemctl. So Systemctl is coming from two words. One, it's coming from the word system, and then we have the CTL, which stands for control. So we can always control the services, the daemons, the sockets, the paths, and everything revolving Systemctl by using a command called Systemctl. Then after that, we will be also in a position to identify those processes that are started automatically or identifying automatically started system processes. And then we will also talk about controlling system services. So in this case, these are some of the things that we're going to cover. Now, what is Systemctl? So the question is, what is Systemctl? So the Systemctl daemon manages a startup for Linux, which includes service startups or starting up services and service management in general. It activates also system resources, server daemons, and other processes both at boot time and on a running system. So it means that for systemd, as long as it's a daemon that manages the Linux operating system in terms of starting up, it also caters, it also works hand in hand in activating system resources. So if we have different system resources that are not activated, then it's actually the work of the systemd to activate those resources, and then again, another resources, especially at boot time. So when we talk about at boot time, that is the point where you will press that button to start your computer or to start the operating system. So it's like you are powering on your computer. That is the boot time. Now, we also have another word here. What is the work of daemons? So daemons are processes that either wait or run in the background. And what is the reason why they are in the background? They are there to perform various tasks. So we have different daemons suited to specific services. So we will talk about different services, and then we will also mention one of the service. And you can see that whenever you have a service, you must have a daemon attached to that particular service. So generally, daemons start automatically at boot time and continue to run until shut down, or until the computer is shut down, or until the operating system is shut down, or until they are manually stopped. So you can decide that your services or your daemons be started automatically by the system. Of course, they will be started automatically by the system, but you can decide whether the system will shut them down automatically, or you can also shut down manually. So as long as the operating system is up and running, there are various daemons that are running. When that operating system is shut down, then some daemons are also shut down. So it means that the survival is in between, as far as the operating system is active, is up and running. Now, it is a convention for names of many daemon programs to end in the letter D. So for example, how do you differentiate, let's say this is a service, this is a daemon? You will always have D, letter D at the end. For instance, here we are talking about the systemd. So systemd is a daemon. And what does it, or what actually shows that it's a daemon? It's actually the D that is at the end. So systemd. Now, that is a daemon. Then what happens to a service? So a service in the systemd refers to one or more daemons, but starting or stopping a service may instead make a one-time change to the state of the system, which does not involve leaving a daemon process running afterward. It's actually referred to as one shot. So it actually gives you an option, and this optionality is actually referred to as one shot. So with services, you see, when you have one or more daemons together, it's like a collection of daemons. Then that becomes a what? It becomes a service. But now the differences between a service and daemon, since the daemons are started automatically at boot time, services can be started or stopped manually. But once it's stopped manually by the user, then it had to make a one-time change to the state of the system. So because why? If you're starting a service, or if the service is up and running, it means that you will be in a position to start that, to use that particular service. But once it is stopped, then that service ceases to be, no longer in use. So that is what generally revolves around what? It generally revolves around systemd. So in this part, we have something else about describing service units. So when we talk about describing service units, we need to understand what are some of these units that are here. So systemd, which is a daemon, uses units to manage different types of objects. So if you want to manage different types of objects, then you must make use of what? Systemd. So some common unit types are listed below. For example, we have service units, we have path units, we have socket units. But what are the differences? You see, you can actually know a unit by its extension. Is it a service unit? Yes. Why? Because it has .service extension. Is it a path unit? Yes, it is a path unit because it has .path extension. Is it a socket unit? Yes, it is a socket unit because it has .socket extension. So that is how you can describe service units by the three options. So what do we mean, or what does services, let's say, for example, those service units that have an extension .service, what do they represent? So all those that have .service extension represent system services. It represents system services. And this type of unit is used to start frequently accessed daemons, such as a web server. Now, so .service extension represents system services. Now come to .socket extension. .socket extension represents something called the IPC, that is the inter-process communication. Sockets, inter-process communication. So we have some sockets which are called like inter-process or inter-process communication sockets, and these sockets monitors the system D. It monitors the system D. So if a client connects to the socket, for example, system D will start a daemon or a daemon and pass the connection to it. Then socket units are also used to delay the start of a service at boot time and to start less frequently used services on demand. So you can decide that instead of a service to start at boot time, you can delay using a what? Using a socket or a service unit called sockets. Now, we also have the last one, which is path, the path units. So path units have .path extension and are basically used to delay the activation of a service until a specific file system change occurs. So some services can be activated manually, some services can be activated, faster. So we have like comparison of activation. But if you want to delay the activation of a service until a specific file system change occurs, then you can do what? You can alter or modify the path units. So this is commonly used for services which use spool directories such as printing systems. So that's why when we talk about controlling services and daemons, one of the services that we can actually understand is, let's say, for example, you want to connect or to link one computer to another, say that we have a communication between them remotely, then we need a service called SSH. Now, so the service is called SSH, which stands for Secure Shell. But the daemon attached to that is SSHD. So each service must be accompanied with what? With the daemon. We also have the printing. We have a service called caps. So you will have caps.service. That is what? It's a service and it has .service extension. So caps.service, SSH.service or SSHD.service. So those are services. So when it comes to caps, is a type of service that helps, that actually does it brings forth the printing part. So if you want to connect a computer, let's say remotely, over the Linux operating system, and you want to print, let's say you want to print a document, then we need this particular service called caps.service. So once you have a service, the service name will actually have all these units. If I have a service called SSHD, it will be SSHD.service. It will be SSHD.socket. It will be SSHD.path. So you can actually put all these three extensions before the service name. So this is about describing service units. So this is how we describe service unit. Now, listing service units. Listing service units. When it comes to listing service units, we are talking about a command called the Systemctl. And for instance, if I can just show you one particular practical, So I have like Red Hat. Now, so this is a terminal. These are the Red Hat Enterprise Linux 8 terminal. And for this case, we have this particular command, Systemctl. So Systemctl is a command used to explore, or is a command to explore the current state of the system. So how do you check the current state of the system? You check the current state of the system by using Systemctl. And again, if you want to understand, let's say more about a command in Linux, we have different options. You can say Systemctl, then space -help. You see, you are seeking some help just to understand more about what the Systemctl. So if I press enter, then you can see that it's trying to give me so many other options. So first of all, the command is being defined, that the command is basically used to query or send control commands to the systemd manager. So we have something called the systemd manager. Now, apart from that, if you want to exit, you can just click Control-Z and you can stop that. Another way, if you want to clear the screen, you can clear. Another way, you can say man systemctl. So man for what? Man for manual. So you are trying to read more about this command. So if you press enter, it will still give you so many options. And you can tell, or you can just have a description, just a good description, that Systemctl is a command used to control the systemd service system and service manager. So this is another way. So if you want to get out, just press Control-Z and then let me clear. And then again, if you want to check, you can have info, let's say Systemctl. Let me just try and see whether we can have also this option. Okay, probably this option is not coming up. Systemctl, let's say info. Okay, so most of the time, yeah, this one is actually a non-operation, but we know that you can use Systemctl or the command name space -help, or you can use man space then the command name. So here we are talking about the Systemctl. So if I execute the Systemctl, because now we are in a position to, we've actually, or we can define the Systemctl as a command used to explore the current state of the system. And I'll be in a position to show you probably how to explore. So let me just run and see what is the current state of the system as far as all the services, all the sockets, all the paths are concerned. So let me just press enter. And you can see that we have a lot of information here. Here we are talking about the unit. So when it comes to the unit, we are actually in a position to know or to tell which unit is this. So in this case, let me just reduce probably my font. And this is how we can reduce it. Let me just reduce it kidogo to 15. Okay, so that we can have a smooth, okay, so let me just make it this. So although it's a little bit messy, so we will narrow it down so that we get something clean. So as long as you type Systemctl, it will give you everything concerning the state of the system, So with this part now, let me just Control X, that means I'm exiting, and then I'll clear the screen. And then now, using Systemctl alone is not important because it does not give you specific thing you are looking for. So what happens is you have to add some options so that it takes you direct to where you are. So for example, if I want to view all the services, you see, if I want to list all currently loaded service units, if I want to load all currently loaded service units, then I need to use what? Systemctl and then list we can say units. Okay, let's say units, space hyphen type, and then equals to service. Okay, let me just press enter and see what happens. Okay, let me just get this done. Yeah, press enter. Okay, so it's an error, so it will be a unit. Okay, what's happening? What's happening? Okay. Oh, yeah. So here is an error. So let me just repair that. Yes. So where was the error? The error, I had actually used like two hyphens. I'd actually used like two hyphens, which I was supposed to use one. So when it comes to this part, you can now see that on describing the service units by path, by socket, by service, you can see that we have what? This is a unit, but we have an extension .service. So this is units. We have load, we have active, we have sub, and then we have the description. So we will need to understand what do we mean by this. So let me take you just a little right, just to understand the unit, the load, active, sub, and description. These are like the titles of the columns. So I'll come back to this point, and this time round, I will take you to this part. So we have the unit. And what does the unit mean? You see, the unit shows the service unit name or tells us about the service unit name. The load. Load means whether systemd properly passed the unit configuration and loaded the unit into the memory. So if it is loaded into the memory, then it will tell you loaded, because that service to work, it must work from the memory. Now, we also have active. Active means what? The high-level activation state of the unit. So it shows the high-level activation state of the unit. So is the service active or inactive? Is the service active or inactive? So this information indicates whether the unit has started successfully or not. So if it is started successfully, it means that the service is active. If it is not started automatically or successfully, then it can give you an hint that the service is inactive. Then what happens to the sub? So the sub is the low-level activation state of the unit, which is actually the opposite of what? Active. So this information on the sub indicates more detailed information about the unit. The information varies based on the unit type, the state of the service, and how the unit is executed. So that is based on what? On the sub. And then the description. Description gives you the shortest or the short description of the unit or about that unit. So you will be in a better position to understand the few things about the service. Now, so coming back to this part. So with the unit now, we are able to understand that this is actually like the service unit. And you can see we have the services. You see, a service used for printing, it's called what? Caps.service. A service for firewall, we have firewall.d.service. So firewall is a service. Firewall D is a daemon. So we all know, and we have a lot of services. Now, for the loaded, it means that it's loaded into the memory. The active, it's active, that means successfully started. Running, they are running. You can see even the one, for example, once we have some exited ones, and then the description. So accounts, let's say the first service means what? It's on the account service. You can come for, let's say, so we have different descriptions. We have a lot of services. So if I press enter, and you can say that we also have those that have failed. They are not active, they are not running, they are not exited, but they have failed. So that needs some bit of configuration so that it can also be brought up and running. So all these are what? All these are the loaded service units. So it tells you which services are active, which services are not active, which services are loaded, which are running, which ones are exited, and so many others. So when it comes to the output, this is the correct way of describing or listing all the services. So you see, one common thing is that we have this particular service. So, and remember when we were describing the service units, we were having like service, sockets, and path. So here it means what? You are trying to list all the service units. Now, if I want to list all the sockets units, I can just replace what? Service to socket. If I press enter, you can see now that all of these have .socket extension, socket, socket, socket. And then if I can come back again and replace socket with path and press enter, now you can see that we have what? We have caps.path. This is for the printing. And then we also have other services or other paths. So we have, other path units. So this is how we do what? This is how, this is how we tend to list all services. So if I repeat it, if you want to list the service, this is the command. If you want to list the sockets, this is the command. That means you want to view what? All the sockets as far as Red Hat Enterprise Linux 8 is concerned. If you go to 7, probably it can give you a different view. And then if you want to go to path, then you can have what? Systemctl list units, space, -, type, and then path. So this is about what? This is about the units, how to, listing the service units. Now, so when it comes to that, we need now to see, how do we view the service states? How do we view the service states? How do we view service states? Now, for us to view the service states, and something else, let's say, for example, you want to view all services. You can also add all. So systemctl list -units -type service -l. For example, let me just give you this. So if I list the services again, you'll see that all these services are done what? They are all loaded. You see, they are all loaded. But what happens if I want to view all services, both loaded and loaded ones? Then I can use what? I can use this extension. So -l. all. So if I press enter, you see it's going to display everything, both loaded, not found. So it will display all services. Not found. So that is how you do it. So you can just add whole, and the same thing happens to socket, and the same thing happens to path. So if you go to socket, press that, you can see that we have all the sockets now. So that is it. If you want to go to path, you can just replace socket with what? With path. Then it will give you everything. And you can see that 4 loaded units listed. So if you put -all, it will give you both loaded and those that are not found or unloaded ones. Now, coming to that part, how do we view? Viewing service units. How do we view? Now, for us to view the service units, we need to still maintain the systemctl what? Still maintain the systemctl command. And viewing the status of a specific unit, we must use what? This command, systemctl, and then the status, and then name of the unit. That means name of the unit dot the type. Is it a service? Is it a socket? Is it a path? So if the unit type is not provided, then systemctl will show the status of a service unit if one exists. You see, let me repeat that statement again, that if the unit type is not found, if the unit type is not found, then if the unit type is not found, then what? Or is not provided, then the Systemctl will show the status of a service unit if one exists. If one exists. So here I want us to show one service, and the service is called sshd dot service. Systemctl status sshd dot service. Now this particular service, SSH is a service, D is a daemon. So SSH stands for secure shell. SSH stands for secure shell. Now, so I'm trying to check the status. Is it active? Is it running? Is it inactive? Is it dead? So I need to check the status of this particular service. So if I press enter, you can see that the service is what? Is active and running. Is active and running. So this one is what? This one is the load, and then this one is the sub. So it is active and running. It is active and running. So that is how you do what? This is how we check the status, or how do we view, or viewing the status or the service state. Now we have other services. You can say we need to have a service, let's say cron D. So we have cron D. So this is what? This is the command. This is the service I'm trying to check the status, or to view the status. So if I press enter, you see that yes, the service is what? Is active and running. So it means that if I want to use the cron D service for creating jobs and all other things related to jobs, then I am able to use it. Why? Because it is active and running. If I want to connect my system or to share some files remotely between my Linux operating system and another operating system or Linux operating system, then I am in a position because of sshd.service. So that is it. Now, so that is about what? That is about viewing service states. And when viewing the service states, we have different output. Let's say, for example, I need to do Systemctl status sshd dot service. Now you can see that we have all this information here. What do we mean by loaded? You see, when it is loaded, you can see that at the end here we have what? Enabled. So a service can be disabled, a service can be enabled. But what do we mean by loaded? So when we talk about loaded, it means that the unit configuration file has been processed. The unit configuration file has been processed. Now, what do we mean by active and running? You see, active and running means what? It means that running with one or more continuing processes, or a process is being run or is active and running. And then again, we can talk about, sometimes you can find active running, active exited, and active warning. So active warning means what? It is running, the process is running, but waiting for an event. That is active waiting, not warning. Active and waiting. So the process is running, but waiting for a specific event. Now, active exited. Active exited, it means that the process is running. Active exited means what? The process is running and it has successfully completed a one-time configuration. So once the process finishes or successfully completes a one-time configuration, then we're talking about active exited, because it has actually done its part. So it has come to an end, exited. So that is it. Again, it can be told that it is inactive. The service is inactive. that means the service is not running. Now, at some point, the service is enabled. For the instance, you can see it is enabled. What does it mean? It means that the service is started, or the service will be started at boot time. Every time you start the operating system, that particular service is going to be started. Unlike the disabled, if this point reads disabled, then it means that once the operating system is switched off or powered off, then it will be, you will be required to actually start the service once the operating system is also powered on. So those are some of the descriptions probably on what you can understand when it comes to that. Now, again, we have verifying the status of a service. How do we verify the status of a service? So verifying the status of a service means that you want to see whether the service is active. You want to see whether the service is not active. So we will be immersing, or I know that we have so many services out there. So SSHD and cron D and CAPS is just but a few services mentioned. So we will stick to those few. Now, how do we verify? So verifying the status of a service, Systemctl command is also used. So Systemctl command also provides methods of verifying, or for verifying the specific states of a service. For example, we can use a command to verify the service unit, or whether the service unit is currently active and running. So you see that we talked about active running, active exited, active waiting. So what happens if somebody asks you, just verify whether that particular service is active and running? So how do you go about? So we will just use Systemctl and then say is active. So it's more like a question, and then followed by the service. Is it active? So if it is active, then you have an answer like a question. So it's like active. So it's like you're communicating with the operating system now. Tell me whether this particular service is active. So is it active? So it's active. So it will return both active or inactive. So for my case, it is active. Now, another way you can also do is check whether the service is enabled. That means to start at boot time. So enable. So is enabled. So if it's enabled, then it will tell you it is enabled. So this is how you do what? This is how you verify, or verifying the status of a service. You see? Another part, you can ask the operating system or the shell, is any service failed, or is the service failed, or has the service failed? So we are talking about what? We are talking about only one service, SSHD. We are only concentrating with one service. So if you're talking about the CAPS or service or cron D, you can still. So here we're talking about whether the unit failed during startup, whether the units failed during startup. So you can see it's active. So it has not failed. It is active. So if you want to repeat the same thing, let's say for this particular service, you want to see for cron D, the service. You see, it is active. You can repeat the same. Is it enabled? Is it enabled? Yeah. And then again, has it failed, or did it fail during startup or one? So we have cron D. Okay. So cron D. Yeah, so active. So Systemctl is failed, cron D dot service. So this is how you do what? This is how you verify. This is how you verify the service units. This is how you verify the service unit. Now, so far, we've actually seen how do we view the service states, how do we verify the status of a service? So we are talking about what? Verify the status of a service. Now, the next part is controlling system services now. So this is where the whole topic lies, because we need to understand how to control system services. So what we've done so far is just introduce us into what services, or what are these services, what are these Daemons, and how do we view them. So here we need to now get into a good part, that how do we start and stop services. So we will be using only one service, this particular service, which is called sshd.service, but still we can talk about the cron D, you can talk about the caps. So we have so many services down there. Just by using Systemctl list -units space type, types, then service, you will be in a position to view all services. Now, when it comes to controlling services, if you remember that these services need to be stopped, or services need to be stopped or started manually for a number of reasons. Now, perhaps the service needs to be updated. The configuration file may need to be changed. So if you want to update, or if the service needs to be updated, then the configuration file may also need to be changed, or a service may need to be uninstalled. Then what? Or an administrator may manually start an infrequently used service. How do you go about that? In one way or the other, you are required to control that particular service. So we have different ways of doing that. So we start to understand, how do we start a service even before stopping a service? So first of all, I will just use the status, just to check the status of this particular service, SHD.service. Now the status here is done what? The status is active and running. So this is the starting point. How do we stop this service? You see, I will stop the service and check the status, just to prove the point that I have initiated, or I have actually done the change. So if I want to start the service, so I cannot start this particular service because it's done what? It's already started. But if you want to start the service, you can just use what? Start. So the only thing that you are required to change is the word start that comes in the middle. So if I press enter, I'll be required to walk us through as an administrator. So I'll just cancel this and then I'll take you back. So you see, in Red Hat Enterprise Linux 8 or Red Hat operating system, or any Linux operating system, we have different privileges. So since we have different activities, we have some level of, or the extent at which we can go as users. So remember, we have like two different users. One, we have a super user who is also an admin, who is also a root user, and is always, a symbol has been given to denote that, or to represent that particular user, and it is the hash sign. And again, we also have the $sign, which represent the regular users. So here it means that when I'm linked up or connected as a regular user, I have less privileges, or I have less rights, or I have less authority to perform something. So especially when it comes to starting and stopping a service, you see, checking the status of a service, I am allowed. Checking the status of a service, I am allowed because I am a regular user. See? But now, trying to stop this particular service, I do not have what? I do not have the right. Or to start, I do not have the right. Let me try to stop the service. So you see, I am required to enter the credentials. So here, we have some limitation. We have some limitation. But once you're connected to a root user account, then you have full permissions to work on that. So what happens is, how do we switch from regular user to root user's account? Just press SU, that is for switch user, and then press enter, and then give a password. Then give that. So you can see the symbol has changed from the regular user to root. So in this case, now I am in a position now to do what? To check the status of this particular service. You see, I am in a position now to check the status of this particular service. And this is an area where I am interested at. Now, there was something that was not going through. Let me stop this service. So I will change the word status to stop. Systemctl stop, then sshd.sub. So I'm stopping the service, and then we recheck whether we can do what? Whether the service is still active or running. So press enter, the service has been stopped. So you see, automatically, I've been taken to the second, to the second line, and nothing has happened. So if there was an error, then I could be there could be some notification, but in this case, no error whatsoever. So I am correct. Now going back to check the status, let's see the status now, whether the status has changed. Now you can see that the status has changed now. From what? Inactive, from active running to inactive dead. So this is what? This is how we work with. So already I have done what? I have actually changed, I've actually stopped the service. Now let's start the service. So what I will change is what? Is this. So if I press enter, I've actually replaced the word status with start. So nothing has given me, that means I am okay, 100% correct. If I go back to status, I will just press enter, and you can see we are back to what? To active running. So it's just a matter of changing what is in between. If you want to check the status of a service, just use this, systemctl status. If you want to stop, you can just systemctl stop. If you want to start, you can just use the word start. So of course you cannot start an already started service or already running service. You will always start a stopping, an inactive service or dead service. So that is how we do it. That is how we talked about. We deal with starting and stopping services. Again, what happens if you want to, let's say, restarting and reloading services? When it comes to restarting and reloading services, what do we mean by this? What is the difference between restarting and reloading a service? You see, during a restart of a running service, so first of all, the service must be running. So you're performing a restart. And during a restart of that particular running service, the service is stopped and then started. So it's like you're killing, it's like you're shutting down the service and starting the service at a go using one command, rather than using start, rather than using stop and then come to start. You see, those are two commands. But using restart, it means that you are stopping that particular service and you are restarting that particular service. So on the restart of a service, the process ID changes and a new process ID gets associated during the startup. So to restart a running service, we must use the word restart. So let's see. First of all, let's check the status so that we can see. Now, with this, we can see that we have a process ID. This is the main ID. The ID is what? 3737. And there's a concept that whenever a restart happens, the process ID changes and a new process ID gets associated. So let me just control Z. So it is 3737. Let's do this. So how do I restart? I will just change what? The word status and put what? Restart. Systemctl restart. And most of the time, whenever I change, you made a change to that particular service. If you want to ensure that the changes takes effect, we also have the reload. So we'll talk about that. So let's see, press enter. You see systemctl restart, and through that particular service. So here we are using like one word to like instead of two words, that is start and stop. Now let me check the status. You see the status that 3737 or the process ID has changed to 3819. Has changed to 3819. So that is how you do what? That is how you restart. This is how you restart. You restart a service, and you can do that with crondy service. You can do that with cap service and any other service. Now, come the reload. What do we mean, or what is the importance of using reload? You see, some services have the ability to reload their configuration files without requiring a restart. Now, this process is called a service reload. So reloading a service does not change the process ID. So which is something that happens when you are restarting. Reload does not change the process ID. It's only the restart that changes the process ID. So, this particular ID, remember reloading a service, when you talk about reloading a service, does not change the process ID. This service is always associated, or this process ID is always associated with various service or with various service processes. Now, to reload a running service, we use what? Reload. So the same concept. We maintain the same thing, then just replace with the word what? Reload. So systemctl reload, then sshd.service. Press enter. So it will actually maintain the same status, active and running. It's only the configuration files that are being affected when it comes to reloading, but the process ID will still be maintained. You see, we have the 3869. So we have restart, we have reload. So you see, it's a common thing. The systemctl will be maintained all through. It's only the service that you're talking about. If you're talking about SSHD, that means you will talk about SSHD. If you're talking about cronD, capsd, and so many other services out there, you can do that. But the adjustment, the argument that should come in between, or that comes in between, will tell you a lot. Is it a restart? Is it a start? Is it a status? Is this the stopping? Is it a reload? And so many other. So by this, we are in a position to restart and reload a service. Why do we restart a service? Why do we reload a service? Now, listing unit dependencies. How do we list unit dependencies? Now, when we talk about listing unit dependencies at this point, is that the units, we have some services, and some services require that other services be running fast, creating dependencies on the other services. So we have services that, like, you see, when you're depending, it means that we have the parent and then we have the child. So for the child to work, let's say, for example, for the child to work, we need the parent to lend a helping hand to the child to work. So it means that a child cannot work without the parent working in the first place. So some services here, in connection to that or in relation to this, is that some services require that other services be running fast, then creating dependencies on the other services. So other services are not started at boot time, but rather only on demand. In both cases, systemd, which is the down one, and systemctl start services as needed, whether to resolve the dependency or to start an infrequently used service. You see, for example, in the CAPS service, CAPS is connected, or CAPS service is connected to the printing. So if the CAPS service or CAPS print service is not running and a file is placed into the print spool directory, that means in waiting, then the system will start CAPS related Daemons or commands to satisfy the print request. So In this case, it means that if I want to list the dependencies, and probably we can do that. Let me just run this Systemctl. Let me just check the status of this service called caps service. Okay, press enter. So you see, display all 562 possibilities were not. And okay, so let me just press it again. So you can see that the service caps.service is active and running. So let me stop this service so that we can see. Okay, so if I come back here, okay, it is inactive. Now there's something I was looking at, it's not displaying, but let me just start the service again. Okay, there's something I'm trying to look at. Okay, so we were actually on dependencies. We are actually on dependencies because, okay, sometimes when you stop this particular service like caps.service, because a printing service, and for my case, I'm not connected, but if I was connected with a printer, then I could have what I was expecting to have. Like at some point, if you decide to stop that particular service, you will get a warning that stopping caps, but it can still be activated by, you see, we have like caps.service. Remember that the service units. We also have like caps the socket. We also have like caps.path. So these dependencies that as long as if you stop the service, that is an extension.service or .service extension, you can still start the same service by using the caps.socket and using the caps.path. So this is what we mean by dependency. So we have the option of using caps.path to start the service. We also have the option of using caps.socket to start the same service. If caps.service is stopped, that is the dependencies. So we have this particular command checking the dependencies, and then let's say sshd.service. So we want to see all the dependencies that falls under this particular service. If I press enter, you can see that we have these dependents, those that depends. So this is the service, sshd.service. So what other things depends, or what other options do we have underneath? So we have all these as dependencies. So why dependencies? It means that if sshd.service is stopped, if this particular service is stopped, then these other dependencies will not work. They will not work because the parent service is not yet started. So that is going to give a what? That is going to give an issue. And if you go even back to clear and say, let's say cronid, okay, .service, okay, cronid.service. Let's see the dependencies. You can see that we have the dependencies. So it's like parent to child. A child depends on a parent to work, to eat, everything. So it is related to this. So for these dependencies to work, the parent service must be started. It must be started. So that is it, and that brings us to something else. So what else? Masking and unmasking services. Masking and unmasking services. So you see, at times, a system may have different services installed that are conflicting with each other. For example, there are multiple methods to manage mail servers. That is, for example, we have the postfix, we have something called the postfix, we also have something called the send mail. And masking a service means what? Masking a service means preventing that service or prevent that service from starting or from being started anyhow. So masking a service prevents an administrator again from accidentally starting a service. That is, if you're talking from the administrator's point of view, it actually helps an administrator from accidentally starting a service that conflicts with others. Masking creates a link in the configuration directories. Masking creates a link in the configuration directories. And we have the directories, especially when it comes to the root directory. We have like /dev/null file, which prevents the services from starting. Now, how do we mask a service? How do we mask a service? For example, if I want to stop, let's say, people from using SSHD or from sharing files or from linking my machine to another machine remotely, how do we go about it? So if I want, of course, if I check the status, first of all, let's check the status. The status SSHD.service. Now you can see that this service is what? Is active and running. But I don't want anybody to start this service. So if I do not want anybody to start this service, it means that I will stop this service. You see? And if I stop this service, if anybody comes, let's say, for example, if you come back to my operating system here and try to start this service by issuing Systemctl start, you see the service will be started automatically. You see, it is going through. And if you check the status, you can see that the service is what? Is active and running. But that is also risky because anybody can start the service. So once the service is stopped, you can do something called masking. Systemctl, and then you say mask, and then shd.service. So I am masking what? This particular service. And I am masking it as a different user. So you see, we have a created soft link. We have something called a soft link, which brings a reference to another file. We have this particular file, which is /null. Let's see, cd /dev/null. Okay. Okay, let's see, / or is it a text file? Dev null. Yeah, it's a text file. So if you want to view the contents of this, because already a soft link has been created to that, if I press enter, of course, nothing is there. And the question is how masking works. So here I have actually stopped the service, and more on that, or on top of that, I have actually masked it. So I have actually done it as a root user. So let me switch back to this particular user. This is now switching back to who? To a regular user. So I'll just use su space RH. Now let's see whether a regular user can start this service since it's already masked by a super user. So I'll just use Systemctl and then start and then shd.service. shd.service. Press enter. You can see that I am required to do what? I am required to put a root user's credentials. So if I give it like, let's say, press enter, you can see what? Failed to start SSHD service. Unit SSHD is done what? Is masked. Is masked. Now, so if you want to start this service, the root user must do what? The root user must unmask. So because it was masked, so unmasking must be done. So I'll just repeat the same statement here. Okay. So I'll just say Systemctl, then unmask. So we have unmask and then shd.service. Press enter. So the masking has been removed. Masking has been removed. So this means what? It means now that I can start the service. So here it means that if I want to start, I can start the service. So systemctl start, and then sad.service. So the service is up and running. If I decide to check the status, now you can see that the service is active and running. The service is active and running. So that is how you mask a service, and that is how you unmask the service and mask the service. So now we also have this other part, enabling services to start or stop at boot time. You see, we talked about enable. Why a service is enabled? If the service is in the state of enable, it means that the service will be automatically started during boot time. That means when the operating system is switched on. But if it is disabled, it means that once the operating system is switched on, you'll also be required to extend a hand by enabling what? By enabling the service. So how do we do that? So if you want to ensure that, let's say, for example, starting a service on a running system does not guarantee that the service automatically starts when the system reboots. And similarly, stopping a service on a running system does not keep it from starting again when the system reboots. So if you want, let's say, for example, you want to enable a service, you can just run systemctl and then enable. And then if it's a service such as shd.service, you can just do that. You see? So here you are using the word enable. And by what we have, already our service is enabled. So if you press enter, that is it. And then if you want to check the status, systemctl status, and then shd.service and press enter. So now you can see that, yes, our service was active and running, but this time round, it is done what? It is enabled. The system is enabled. So what happens is, when we talk about this, it means that if you switch off or if you power off your operating system, then automatically the service will be up and running. But if it is disabled, then the service will not be up and running. It means that you will be required to start it or to enable it manually. So to start a service at boot time, we need to run that command systemctl enable. So that will do that. But if you don't want it to start at boot time, you can just replace what? Enable with the word what? With the word disable. So if you press enter, you can see it is removed. But checking the status shd.service, you can see that it is what? Disabled. It is disabled. So it means that the service will not be enabled at boot time by default. It will not be enabled boot time by default. So if you put enabled, it means that it will be enabled at boot time by default. Disabling means you will be required to enable that service once the operating system is up and running. So by default, we can just make it appear or have the status of enabled. So that is what? That is enabling services to start or stop at the boot time. Now, the summary of systemctl commands. These are all the commands that we've actually seen so far. And you can see that we have the command like systemctl. Let me just do this. So if you want to view detailed information about a unit state, if you want to view detailed information about a unit state, then just use systemctl status followed by the unit. Whether it is sshd.service, sshd.socket.path, you can use that. Stop a service on a running system, just use systemctl stop followed by the service name. Start a service, just use start. Restart a service on a running system, just use systemctl restart, then followed by the service name. If it's about, we're talking about now the unit. Is it sshd.service? Is it sshd.service? .socket? Is it sshd.path? Then you can reload, you can mask, you can unmask, you can enable, you can disable, and then finally you can also list dependencies. So all these things we've actually gone through. And it is now high time for you to practice, practice. So we always have like practice makes improvement. So in Linux operating system, we require that you practice a lot, and the more you practice, the more you get to understand. And then on the summary part, so in this particular topic, we've actually learned that systemd provides a method for activating system resources, server daemons, and other processes, both at boot time and on a running system. We have a command called systemctl, which is basically used to start, stop, reload, enable, and disable services. And then we also have systemctl status command, which is used to determine the status of the system daemons and network services started by systemd. So you've seen that we've been concentrating so much on a daemon because we are talking about a service which is a collection of one or more daemons. So that's why we're talking about SSHD, cron D, caps. You see, we have DDD coming at the end. Then we also have the systemctl list dependencies command, which lists all service units upon which a specific service unit depends. Systemctl list space dependencies command lists all service units upon which a specific service unit depends. And then lastly, systemd can mask a service unit so that it does not run even to satisfy dependencies. So now we are in a position to understand the dependency. What depends on what? So I had actually given an example of a parent to child. Child depends on parent. So for a child to walk, for a child to eat, the parent or the child, the parent needs to put some more effort to ensure that that is happens. So for a service or for a service dependency to also operate or to function, the parent service must also be active and running. So in short, that marks the end of this chapter 9, which is all about controlling services and daemons, So thank you very much for your time, and